All right. Hey, guys. Let's start on how we actually see vision, okay? How image formation actually works in binocular vision. Okay, first thing that has to happen is we have to have refraction of light rays. And remember, refraction of light means bending the light. And we actually bend it quite a bit because we change a lot of densities as we travel through the eye or as an image travels through the eye. So if you look right here at this one, this PowerPoint, let's see. Let's go ahead and get that PowerPoint. Sorry, not doing this very good. Okay, raise your hand if you're not surprised. Okay, so here's refraction of light. So here's a tree, and as it travels in, it's going to go through the cornea, a change of density. It's going to go through the aqueous humor, a change in density. It's going to go into the lens, a change of density. And then it's going to go through the vitreous humor, a change of density, until it hits the retina. And it is so refracted by the time it hits the retina, it's flipped over and upside down. Okay, so we have to change that back correctly in our brain. The brain flips it around correctly. Okay. The second thing that has to happen is accommodation. And that means that we have to be able to take in the image and make it land on our retina in focus. Okay. So the lens itself is convex on either side. You can see that right here. Sorry. Ugh. Okay. In a perfect world, it's going to hit your retina like that, and the lens is going to be perfect for it to hit the retina on the back. So that's what we want. But where it hits on the retina depends on the actual shape of the eye. So our eyes can sometimes be misshapen. On a normal eye, it's going to hit the retina exactly right. And this is a normal or epitropic eye. If you are nearsighted or myopic, that means that your eye is actually a little bit too long in shape. So where it hits in focus is before the retina. This would be nearsighted. You could see things up close, but you couldn't see far away. This is farsighted or hypermetrophic or hypertrophic. And this means that the focal point is actually beyond the retina. Your eyeball is actually too short for it to be in focus. So the actual focal length falls behind the eye. Let's go back to the word again. So both sides of the lens are convex and we have to change shape. Okay. If I'm looking at something close up, the lens is going to be flatter than, the lens is actually going to be more round as I'm looking at something close up. And it's actually going to be flatter when I look at things far away. So when I'm reading, I have to make my lens very round by contracting the ciliary muscles. And if I'm looking far out, like to see the trees out the window, then my lens is flatter. Emmetrophic vision, like I said, is normal. Myopic, nearsighted, you have a longer shape of the eye. And then remember, nearsighted means you can see close up. Hypermetrophic or hypertrophic is farsightedness. So you can see things far away, but not close up. You have a shorter shape of the eye. Then there's something called astigmatism. Some of y'all might have astigmatism, and this is where either the cornea or the lens itself has an irregular curvature. Like it would just be part of this lens that was irregular. So part of it stays in focus and the other stays out of focus. It's not the whole lens that's affected, but it's a misshaping of part of the lens or part of the cornea itself. Presbyopia lens loses the elasticity of the lens, and this happens in old people after 40. They be so old, and they lose their ability to see close up because their ciliary muscles cannot contract this lens like that because the lens loses elastin, so it can't become as round as we need to see close up as we can whenever we're younger. It can become more rounder because our elastin works really well. As we get older, the elastin loses its elasticity and the lens cannot become as round as we need to see close up to read things. That's why old people have to hold things so far away from their eyes and everything to see, because they can't see it any closer. Okay, so that's accommodation. Then we have constriction of the pupil, dilation and constriction of the pupil. Remember we talked about that before when we talked about the ciliary and the radial muscles. And then we have actually convergence. That's how we see binocular vision. It goes and it focuses on one object for us to get one image. And that convergence is the name of the movement of the eyes toward the midline to see one object. Like theoretically, we see two and we combine the pictures together. All four of these things have to happen to be able to form a vision. Next, we're going to talk about photoreceptors. It's very detailed in the book. I'm only going to tell you what I need you to know. Y'all have a great day.